Hello, everybody, and welcome to today's webinar about Amazon SageMaker Autopilot. I'm Evgeny Ilyin, an AWS Senior Solutions Architect in Switzerland, and I'm responsible for enterprise accounts and specialize in machine learning and data analytics. So first of all, we see and we learn how to leverage a very simple drag and drop UI to do data preparation and feature engineering called Data Wrangler. And I explain later why Data Wrangler could be very important for you, even if you use AutoML from AWS. The second thing we're going to learn is how to use Amazon Autopilot to build machine learning pipelines for your tabular data and do it completely automatically. And the third topic, I'm going to show you how to leverage a SageMaker API or SageMaker Python SDK to programmatically implement all AutoML steps in your notebook or your machine learning pipeline. Everything what I'm showing today is available as public immersion day. You can click on the link or go on QR code. And this is very nice workshop, contains a lot of code, notebooks, data sets. You can use your own data sets. You can experiment with notebooks and so on. I encourage you to go there and take a look. In terms of time, so what we're going to do today, we spend next half an hour or so looking at low-code, no-code capabilities within SageMaker, set the scene. Then we understand what SageMaker Autopilot, how it works, and how you prepare data for Amazon SageMaker Autopilot using Data Wrangler. And we also look at use cases we are going to work today and use which data we're going to use for Amazon SageMaker Autopilot. And as a main part of the workshop, 45 minutes or so, we look at 4 labs. In the first lab, we train a multi-class classifier using a healthcare data set. In the second lab, we train a binary classifier using financial services data set. In the third lab, I think it's the most interesting lab, for me at least, we process the data using Data Wrangler. We process the time series and prepare this data set for Autopilot. And then we use Autopilot to predict data on time series. So you learn how to prepare data, how to prepare time series, and then train model using AutoML. And eventually, in the last lab, we go through a notebook with SageMaker Autopilot using Python SDK. So you can programmatically do everything what you see today on the screen. And finally, I'm going to show you a couple of links for SageMaker documentation and useful resources like blog posts, workshops, or scientific papers. First, let's look at a typical machine learning workflow. In the first step, we prepare data, we do data preparation and feature engineering. Then we use this prepared data set for our model development. We actually have to write some script and use different approaches, different model types. Then we train the model and do some tuning. We decide with which hyperparameters we start and how we continue with hyperparameters to hyperparameter optimizations. And we repeat all these 3 steps again and again multiple times. So this is highly interactive and also time-consuming activity. And at the end, when we're happy with the model performance and approach we're choosing, we use the model, we deploy model, and we run offline or online inference. With this machine learning workflow, of course, some challenges come in. First of all, and probably the most important and the major blocker. To implement this, you need really deep experience and expertise, understanding the data, understanding how model works, understanding how different hyperparameters affect model performance, training time, and just the fact that you can train. This all requires literally years of experience. And experimentation is time consuming, and it's sometimes highly manual. You have to go write some code in the notebook, go iteratively through the code, and do same thing again, only changing some small bits. Could be also compute resource intensive based on the data set, based on the use case. For example, NLP or computer vision. You potentially need expensive compute resources with GPU, a lot of memory, or a cluster of compute resources. And another problem coming from human resource perspective, data science teams are oversubscribed, have a huge backlog, and very difficult to get into this backlog. So one of the remedy could be produce and provide set of tools to citizen data scientists, people who are not necessarily very familiar with the models and with having this experience how you train a model, prepare data, do the feature engineering, but people who understand the data, who works with data every day, day to day, and they also use some tools to get data insight. So if you give proper tools, and I'm talking about AutoML here, to these people, you can increase productivity of your machine learning workflows in your company manifold. And in Amazon SageMaker, we have a concept of low-code and no-code machine learning tools that gives you really this opportunity and options to do machine learning things from workflow, like a feature engineering or model training, very fast. And you see here a couple of quotes that you can build your feature engineering pipeline within days and not months. You can automatically build, train, and tune automatically hundreds of models in parallel, and do it not manually but automatically, and get the best one. And overall, you can reduce your production time to production for machine learning solution to a couple of weeks instead of many months. So first of all, look at low-code, no-code machine learning offering from AWS. 3 of these capabilities are low-code and available in Amazon SageMaker Studio, and the 4th capability is no-code. So you literally have no option to write any code there. But first, look at Data Wrangler, is the first capability, and it provides a super easy visual interface with more than 400 pre-built data transformation. You can drag and drop into Flow, and then you create your data exploration, visualization, data processing, and feature engineering pipeline. And you don't need to write any single line of code. A good thing with Data Wrangler, if you don't see the transformations that you need within these 400 pre-built data transformations, you can implement your own transformation using Python or PySpark or SQL code. So it's very flexible. You're not only limited to transformations that are provided for you, but you can use this transformation in a very simple way. They're all machine learning oriented. For example, how to handle your numeric features, how to handle your categoric features, how to handle data series, missing data, and so on. Today, we are going to dive a little bit deeper into Data Wrangler. We're going to use Data Wrangler to process data set for Autopilot, so you'll see on your own. The second capability is Autopilot, and this is the topic of today. Just think about Autopilot as an AutoML capability end-to-end. You provide it a tabular data set, and it's automatically infers a machine learning type Is it linear regression or multi-class classification or binary classification, and so on? It automatically creates data preparation pipelines, feature engineering pipelines, develops different machine learning models, also does hyperparameter tuning of these models, and eventually gives you back the most optimal combination of all this. And you can also automatically deploy the best model into production. So this is really end-to-end AutoML. The third low-code capability is called Jumpstart, and it has more than 300 pre-trained state-of-the-art models for computer vision and natural language processing. So you can use this model as is, or you can very quickly tune this model using your own data. So using transfer learning, and do everything this from very simple UI. Just think about Jumpstart as a set of advanced models like GPT-2, BERT, different flavors of ResNet, and you can super quickly leverage this model or fine-tune, build your own, and use it, and do it really in a matter of minutes. And lastly, no-code machine learning capabilities, Canvas. And Canvas gives to business analysts end-to-end tool to load data set, do exploration, also visualization, and run AutoML on this data set and end up with a model, and you can run already prediction on the model. Everything in one single UI without really deep understanding what machine learning is, how you define metrics, what is machine learning model performance, and so on. So it's really accessible, and you can give this tool to business users. And so if you're interested really to have more insight into different low-code, no-code capabilities like Data Wrangler, Jumpstart, Canvas, just browse AWS webinar library, and you'll see there are also webinars in depth describing this offering as well. Let's look what we are going to see today. 3 use cases. In first use case, we predict patient readmission into hospital. We train multi-class classifier. We prepare data using Data Wrangler and then run Autopilot. In the second use case, we dive deep into financial services data set. We use loan defaults data set. Again, we prepare data with a Data Wrangler and run Autopilot Experiment. We're using a tabular data set from Lending Club, and we do the binary classification, meaning we define if this specific loan is going to be default or not. And the last lab, we work with time series data set from Global Historical Climatology Network data set. We extensively use Data Wrangler to do feature engineering on the data set and to prepare this time series data set for Autopilot. And then we run Autopilot Experiment. Our goal is to predict an average temperature for a specific day. And as a bonus, we also show today how we can use SageMaker Python SDK programmatically in the notebook. And we provide source code, and you can see you can run everything programmatically in your pipeline or your specific workflow. Okay. First of all, let's look at Amazon SageMaker Data Wrangler. So, but before I start with the Data Wrangler, it's important to understand SageMaker Autopilot is a standalone thing. So you can generally take data set, tabular data set, and give it unprocessed to Autopilot. And this is also a beauty of Autopilot. So Autopilot automatically infers the use case, what it is, linear regression or binary classification, multi-class classification. It automatically does the feature engineering and data pre-processing, processing your categorical features, processing your numerical features, scaling your features, for example, or handling missing data and so on. And this is all done automatically based on your data. But sometimes, if you can pre-process your data and do some feature engineering before you give data to AutoML, you can achieve even better results. And for this, you can use Data Wrangler, completely visual tool. So let's jump into the high-level definition, high-level workflow of Data Wrangler. So first of all, you select data sets. And you can select data sets from different data sources. You can connect to Amazon Athena directly and load data from tables through query. You can, of course, tap into the data set which stored on Amazon S3. You can also go to Amazon Redshift, or you can also use Snowflake access to get your data. So you load one data set or multiple data set into the Data Wrangler, then you can do visualization with a set of predefined diagrams and visualization, or you can run your own visualization. And then you do the set flow of some transformation, feature engineering, data cleansing, enrichment, and so on. At the end, you produce a so-called flow file that, in combination with your data, creates an end-to-end workflow that you can use in your production environment, your operation environment. So you can take any data set, apply this flow, and produce a final data set. Data Wrangler flow integrated with Amazon SageMaker pipeline, so you can run it directly from Amazon SageMaker pipeline as a processing job. You can also ingest data directly into SageMaker feature store without intermediate steps. Process your features in Data Wrangler, ingest directly into the feature store. Very convenient. Or you can run Data Wrangler processing as a standalone processing job, as a part of the bigger pipeline, or just a part, run it from the notebook and process the data. Visually, it looks the following. You select data that you want to import, select source, or add data connection. You can import data in various file formats. Data Wrangler supports CSV, Parquet files, database tables, supports different set of delimiters. You can define if file has a header or not. So you have all these options on user interface. You can implement, as I said, different visualization. There are a set of pre-configured visualizations like histograms and scatter plots, box, whisker plots, line plots, different bars, and so on. If you don't have a suitable visualization, you can implement your own using Altair framework. It's very flexible in terms of data analysis. And transformation. This is what Data Wrangler is all about. You have over 400 built-in data transformations, machine learning focused. So you can manage your columns like renaming, joining, splitting, dropping column. You can do different things based on regex, like finding and replacing. You can handle missing values, missing numeric or missing categorical values with different imputation strategies. You can balance your data set if you have an unbalanced data set using quite advanced strategies as well. And you can implement also your own transformation in PySpark, SQL, or Python pandas. It's a very broad range of tools that is available in Data Wrangler. Another very interesting option in Data Wrangler, you can run so-called quick model, and quick model takes a subset of your data and run a random forest model on this data and gives you indication, first of all, what model performance can be achieved on this data in terms of different metrics like F1, and it also shows you the feature importance. Also, how specific features in your data set affect the target. And you can use these quick models to estimate what is impact your data transformation on the data set can have. For example, you run quick model, you see its specific performance, and then you implement a couple of new features to do some feature engineering. For example, do one hot encoding or scale your numeric feature. You run again this quick model, and you see how the model, for example, accuracy changes, or you see how the feature importance changes. So it's very important interactive process that gives you immediate feedback on your transformations. And Data Wrangler gives you possibility to visually create your workflows. You can combine different data sets using joins. You can also split data sets by delimiter or by different rules. So you can prepare your train, test, validation data sets, and you can specify different destinations for your target data set. And you can specify multiple destinations in parallel. For example, you can create a workflow that will do some data preprocessing, then implements feature engineering. Feature are ingested into feature store directly. And then, for example, you can store your data set in some location in S3 for further use. Okay, we will look at Data Wrangler today. As I said, we do some data pre-processing for Autopilot, but now let's jump to Autopilot. And before we go into the demo, let's see how SageMaker Autopilot works. In the nutshell, you provide data set, you say what is target attribute or target column, and then SageMaker Autopilot does the rest. So Autopilot analyzes your data, infers problem type, is it linear regression or binary classification or multi-class classification. It handles your features, for example, do something about your categorical, numeric, listen data, implements and imputation strategies, does feature engineering, then selects a couple of models and implements pipelines with these models, including the model hyperparameter optimization. And at the end, you have a set of artifacts which include different metrics, like a model metrics, model itself, so models itself, all models are trained by SageMaker Autopilot. You can specify how many models are trained, and by default, we train 250 models. Then set of notebooks with source code, with the pipelines and data preparation, data exploration, so you can use it as is, or you can use code snippets in your projects, in your pipelines, and it also generates an explainability report, so to see how model results are explained by your data. And if we go a little bit deeper and see how SageMaker implements this workflow, we have different stages in the workflow. SageMaker processes the data, does all the data split into validation and training folds. It also creates a feature engineering pipeline depending on your data. It also does some transformation and use different model types. For example, it uses linear regression. SageMaker Autopilot uses deep learning, multi-layer perceptron model, and also decision trees model. For each of the models, SageMaker Autopilot builds a pipeline, including feature engineering and hyperparameter optimization, and Autopilot runs these pipelines in parallel. So you train, so Autopilot trains 250 different models for you, and at the end you have these models ranked by your objective metric. You select also object metric, could be accuracy, could be F1, could be area under curve. And you also have a possibility to automatically deploy model in production. All this functionality is accessible through a simple user interface inside SageMaker Studio. literally you point to S3 bucket. If you have your data set on the S3, you specify a couple of things like a target column. Of course, it's integrated into security controls. You can specify VPC as an attachment, security groups, encryption key for your S3 data, for your model artifacts, and so on. You also specify if you want to run a complete experiment, can take multiple hours, or you can want to run only a short experiment. You can limit time, you can limit amount of jobs created by or models created by Autopilot. So you have full control of what is going on there. And you also specify what model evaluation metric you would like to optimize. And you have full visibility and progress. Autopilot shows you in user interface what current stage Autopilot is working on, what jobs are there. You can go to each job descriptions. Each job is also available to browse and to get details in AWS console, SageMaker console, or through API. So this is completely white box AutoML. You can also anytime stop the whole process if you think it goes wrong direction or you're already happy with the performance. And you also can browse the source code generated by Autopilot, for example, model creation pipeline, or explore hyperparameter ranges, how it's exactly optimized, and rerun it with your own settings or use it in your pipeline. And you can override multiple things in Autopilot. Some of them you can provide your own evaluation metric, objective metric to optimize. You can provide your own hyperparameter ranges. You can provide what compute instances SageMaker Autopilot uses, what algorithm are considered, and so on. So you have these sets of knobs to turn and to optimize Autopilot. Okay, it's time for a demo. Everything, again, I repeat here, everything what you're going to see today is available publicly as AWS Machine Learning Low Code Immersion Day. Just go there and browse it. You can follow the notebooks as I showed you, or you can do on your own pace. You can go back, you can experiment, you can change code, of course, use your own data set. So it's really rich experience and a lot of information there. Let's start with the first lab. In this lab, we're going to train multi-class classifier on a hospital readmission dataset. This dataset has 10 years of data of clinical care, contains 130 US hospitals, and has some patient demographics, some laboratory data, has 70,000 rows and 15 features. First, we're going to do some feature engineering, data visualization using data Wrangler, and then we run this data set, process data set as an Autopilot experiment. I'd like to say here, you don't need to pre-process a data set before start an Autopilot experiment. You can give your data to the Autopilot as is. Autopilot is designed to do data processing, feature engineering, handle different data types and different situations like missing data, combinations of features, and so on. But sometimes you can achieve better results if you do data pre-processing and some initial feature engineering, and then pass data set to an Autopilot. So you can implement a kind of pipelines. First, you process data with data Wrangler, do feature engineering, and then you run an Autopilot experiment to train and do hyperparameter tuning and to produce a most optimal model. Let's go to the lab itself. I'm running here a public AWS Machine Learning Low Code Immersion Day. So all notebooks, all data sets, and instructions, tips, and hints, all available publicly. You can look at your own pace, come back here, use this code, experiment with this code, and so on. So it's really a great deal of resources in this workshop. Prerequisite for running this lab, if you want to do alone, you must have your SageMaker Studio environment set up. How to set up this environment, everything described here, step by step. What you have to do, you go to your account and create a SageMaker domain. You can use a quick start, or you can create a domain in a specific VPC. You create the EM role. You configure your domain, you start your domain creation, and then you start your SageMaker Studio. So I assume you have this already, and then jump directly to SageMaker Studio. I'm starting with this lab here, Healthcare and Life Sciences lab. And as I said, we're going to predict hospital readmission. To get the data and the notebooks, the source code, again, follow these instructions. So you have to open your SageMaker Studio, go to terminal, and run this couple of code. So creating directory, follow code, no code. You install unzip. Then we get source code and dataset, and we unzip, and we end up with this folder in Studio with dataset and a notebook. So let me go to Studio. I assume you're familiar with Studio interface. If not, it's very simple. To open launcher, you either can go to File and say New Launcher, or you click this button and your launcher will be started. And launcher your central hub that allows you to start different things in Studio. You can start new data Wrangler flow. We're going to use it today, or you can work with a feature group. You can work with ML projects and so on. Autopilot Experiment, again, going to start it today. If you want to start System Terminal, just click here and you're in System Terminal. Don't forget to run this code to get the data set and the source code. Okay. I have already data set in the folder in SageMaker Studio, and I have a notebook. You can open the notebook, very simple notebook. We load this data set. We look at this data set. As said, it has 15 features and one target column called readmitted, and it represents basically after how many days a patient readmitted back to the hospital. And so we have some values: 0 if patient was readmitted in less than 30 days, over 30 days, and no if there is no record of readmission. And we have 3 classes here, so this is multi-class problem, and we want to predict this problem. And then we have some information, race and gender and age, some demographics of how many times in the hospital. We have some numeric data on amount of laboratory procedures, medications, and so on, diagnosis. And we have some also categorical data. As you see, a lot of those is known. You have full description of the data set in the notebook or in the instructions. I copy this data set to the S3, just AWS command line command. And I need this path to the S3 object, because now I'm going to start data Wrangler to pre-process the data. So again, to start data Wrangler, the easiest way, you go to launcher and say a new data flow. start, and we want to import new data set, the data set on the S3, and I can specify exactly this file, hit go, wrong bucket name, of course, and hit again, and we have this data set. The data wrangler does a preview, and you have different controls. How can you load this data set into memory? Everything what we're going to do today, and now on the screen with data wrangler, this is in memory processing, and data wrangler runs in my SageMaker studio. If you go to the running terminals on kernel, you can see exactly what instance is data wrangler running, and this is ML M5 4X large with the 16 virtual CPUs and 64 gigabytes of memory. So the controls that you have here, you specify what is a file type, and you see data wrangler can accept Parquet, JSON lines, org, and we can also specify first row with header. We can specify the delimiter, and we can do the sampling, which is very important for big data sets. You can specify sample size if you don't want to load full data set in memory. And you can specify how data wrangler samples the data from this data set. So we can take first K or do the random or stratified. Let's say I say I would like to have stratified, and we know the data set is 70,000 K. So let's do here, take only 40,000. And now I need to column to do the stratification, and I take my target column, which is readmitted, and then I can import. Okay, data set is loaded now, and first what we can do, we can first browse the data. We can see the data types here, and data wrangler automatically infers the data types. If some data type is incorrect, you want to change, you just do it here, and this is captured as part of your transformation. First of all, would like to create a visualization. So I'm going to Analysis tab, and I select what type of visualization I would like to have here, and say we would like to have the feature correlation. We select feature correlation here. We can apply a name. And we select what correlation type we're interested in. Could be linear, it could be non-linear. So let's select linear and hit preview. And data wrangler now calculates feature cross correlation. It takes probably 30-40 seconds to calculate all this. Okay, we have now analysis right now, and data wrangler estimated or calculated feature correlation. So we have for each feature with each, and we have correlation metrics. So we can infer some useful information here. So we save this visualization. We can use it later. And now let's create a new one, and let's create a quick model. So to see what kind of performance can be achieved on this data set. I would call it quick model. And we need to select a label, which is readmitted. And we again click preview, and it takes probably a minute for data wrangler to create a quick model. So what is happening behind the scene here? Data Wrangler does some data pre-processing, and for example, algorithm encodes categorical features to vector, and does some encoding for labels. Then it takes 70% of the data and trains a random forest algorithm. And after it trains random forest algorithm, it calculates the performance and so on. It's actually everything written here, how many observations. We trained 10 trees, and now we see that F1 score of the model is 0.48 on the test set. And we also have feature importance here. Okay, let's save it. So you see it's very easy to do the visualization and exploratory analysis of the data with Data Wrangler. Now let's do some feature engineering. We go back to the data flow and we add transform here. So we have two steps, the first load and the second the setting data types. And let's add a new step. And we, for example, would like to manage our columns. Again, I do quite arbitrary data processing here and feature engineering, depending on your specific use case and a data set. You can do what you think is important for this data set and look what is available in the toolbox and process your data. So I would like to drop a couple of columns that I think it's not important. Again, based on the analysis, not important for the model. So let's drop these columns where we have a lot of missing data. We drop this one. You can select multiple columns in one operation. We drop this one. We drop gender and number of procedures and number of outpatient. Every time you click preview, these transformations are applied to your data and you have processed data set already on the screen. And if you're happy with the result of the transformation, you hit add, and this transformation added as a step to your flow. Let's add another step, and let's handle categorical values now. And for example, I would like to do one hot encode with categorical column called race. You can also specify handling strategy, so what to do with invalid value. And I would like to keep it. You can drop last, which is also normal practice, and you specify what kind of output style you would like to have a vector. I would like to have a columns, and then you again hit preview. And you see that we have this one hot encoding at the end of the data set added. We have these columns with the zeros and ones, and original column is removed. So we implemented one hot encoding, and we click add. Okay, and so you can do additional transformations, additional analysis is up to you. What you think when it's enough to massage the data to do the feature engineering. So at this point, I would like already to export my data. You have multiple options how you can export data from Data Wrangler. The easiest way probably in this screen, you can hit export data button and the data will be exported. What we have now in the memory, the data set is already processed here. This data set you can export so-called in situ to S3. To export data, you have to specify S3 location, let's call it patient admission. And you can specify file type, you can select Parquet, delimiter, compression, and of course you can specify encryption key for your data. We click export data. It takes probably 20 seconds to write data on S3. We have it already. This is location. We copy and just get file name, run AWS S3 list on this location. And this is the file name. So we need the path to the object, the transform data set, to provide it to Autopilot Experiment. Now we run a new Autopilot Experiment. The easiest way to go to Launcher and click New Autopilot Experiment. And I have to specify here name. Let's call it patient readmission lab 1. And we enter S3 bucket location. And we copy paste it from here. And we need object itself. This is named like this by Data Wrangler. And we have to specify target now. So you see the Autopilot already read the data, and we have our all columns here. So you see we have only columns that in the data set. So we dropped a couple of columns in the transformation phase, and these columns are not anymore here. So this is transformed data set. And readmitted is our target. We can auto-deploy model at the end of the experiment by keeping this on. I don't want to auto-deploy models, so I switch it off. And now we go into advanced settings. So we see what you can change here. Of course, you can change machine learning problem type. You can keep it on auto. I can explicitly specify this is multi-class classification and objective metric. I would like to have F1 macro here. And how I would like to run my experiment. If I want a complete experiment or only the pilot, yes, I would like to have a complete experiment with 250 candidates. And you can specify the different limits here. For example, how long each trial can run, how many candidates, multi-chop runtime for each candidate, and so on. You can specify the different security things like execution role, encryption, VPC, and so on, attachment to a specific SageMaker project and text. So from operational perspective, it's quite elaborate settings. So let's check that I have everything here, and we also have to specify where I would like to store all artifacts. And we can use basically the same location. Just write Autopilot. So I'm ready to run experiment. If I click create experiment, I redirected to experiment progress control pane, and I see the different stages of Autopilot experiment. So first we do the pre-processing, then generate candidate definition pipelines. We do the feature engineering, model tuning, explainability report, and insights report. The full experiment on this data set will generate 250 models, and it takes probably about 2.5 hours. So you see, it's already started as a pre-processing, and we're going to see all jobs, all trials started by Autopilot here. You can also go to our AWS console, SageMaker console, and you can browse all Autopilot jobs. Here, for example, go to processing jobs, and we see some jobs in process, and this is creating pipelines. And this is our experiment. As you see, patient readmission, lab 1. Go back to studio. At any point, you can stop experiment if you, for example, want to change something or happy with the result. We don't have any results here because it's still pre-processing. As I said, it probably takes about 2 hours. As we are running a cooking show here, I'm going to stop here and come back when the experiment is ready. Now our Autopilot experiment is done, and you can browse all experiments and trials and also Autopilot experiments in SageMaker resources pane. You go to this pane by clicking on this icon, and you can select the different widgets. You can access to projects, for example, for data Wrangler, feature stroke pipelines, and so on. And to access SageMaker Autopilot experiments, you have to go experiments and trials, and SageMaker experiment will be one of those jobs in this list. So I click on our patient readmission prediction experiment, and I click describe AutoML job, and I see that the job is finished. This is result. So this is the best model with our objective metric, which is 0401. And this is our objective, so our optimization objective. And we have some other metrics like recall, accuracy, precision, balance accuracy, F1 macro, and winning algorithm. You also have a full set of jobs that SageMaker runs, so the different models available here. For example, if we go to this model and click open model details, we can see what is the status. We see this is a multi-layer perceptron, fully connected network, algorithm, problem type, job name associated with this model, model name, and so on. But let's go back and browse for the best model. So these models are ranked based on our objective metric. Of course, you can rank based on accuracy. Or other metrics. And let's go to the best model and look into the details. We open model details and see this is the best. The winning algorithm was deep learning, fully connected fed-forward network. We also have some explainability report. So for each of the label, under 30 days, over 30 days, no data, no readmission. We have information how each feature is important for prediction of the specific label. We have all the full set of metrics here, and we have set of winning hyperparameters for this model. And so what we can infer here, for example, we see the activation function. We see some regularization parameters like a dropout and embedding size. We see layers, so 3 layers with a 200, 150 neurons, learning rate, for example, batch size, and so on. If we're happy with this model, we can also deploy model directly from this screen. So we click here, deploy model. We can select parameters for real-time endpoint of SageMaker. Not going to deploy right now. Or you can take this model artifact and create a batch transform, batch inference, for example. So it's up to you what you are going to do with this model artifact. If we go back to to the description screen, to experiment screen. We have two buttons here, one for candidate generation notebook and one for the data exploration notebook. So if you open it, this notebook is generated specifically for this project. And you can import, so instantiate this notebook in your local directory. And then we see here that you have full source code, for example, creating candidate pipelines. And so what we see here is that SageMaker generated 9 machine learning pipelines and using 3 algorithms. And you can see here, this is one pipeline using XGBoost algorithm. This is also using XGBoost, which just has different settings. I have also XGBoost. This is linear learner, so for linear regression, XGBoost again, XGBoost, and somewhere we go to here. This is MLP. So this is pipeline with our winning algorithm. And you can go to data exploration notebook. Again, so you have some analysis on your target label, so how you distribute it, if you have balanced data set or unbalanced data set, with the data sampling, finding duplicate rows, cross-column statistics, and so on. Again, you can instantiate it and use it in this project, or you can use code snippets from this in your other projects. So this is fully transparent what is going on behind the scene. Okay, I think we're done with this lab. You can go to the workshop and run the same notebooks, the same experiment with this data set. You can apply different data preprocessing using Data Wrangler, or you can use this data set directly without any preprocessing to run Autopilot Experiment. Let's move to the second lab now. In the second lab, we also take a tabular data set and run an Autopilot Experiment with data set. We try to train a binary classifier. It's a little bit different use case. We use the data from a lending club, and it contains complete loan data for all loans, and we try to predict which loan is going to default and which is not. To run the lab, you have to copy first source code and the data, exactly as a lab 1. It's all publicly available in AWS workshop. So you have to copy paste these comments into terminal in Studio, and data will be downloaded into your local directory and extracted here. After that, I'm going to run this notebook. The notebook, exactly, we follow the same procedure in lab number 1. We look at the data set. Some features are numeric, some features are categorical, and loan status is our target column. We upload data set from EFS to S3. And interesting, we have here 2 parts of the data set, part 1 and part 2. We are going to join these 2 data sets in Data Wrangler and produce in one data set, and then we do some processing, and resultant data set we going to give to SageMaker Autopilot. So let's start with Data Wrangler flow. Again, go to Launcher and start a new data flow. Go to import our data set. Specify S3, and I need a pass. And this one, it's part 1. So we click import. And we go to import again, and we import the second data set. Hit import. So now you see we have two data sets, and now we're going to join. So we select right data set, and then we're going to select left and right, and configure. We want to have inner join on ID, and you have preview. As you see here, we have some reference data about a loan taker, like employer title, home ownership, annual income, and so on. And this data set is about loan itself. So we hit preview, and this is our joint data set. And we click add, and this is our data set. It's already in flow. Okay, let's do some feature engineering and data transformation. So first of all, I would like to drop the column that we don't need. Go to banish columns and drop column ID 0 and ID 1. Always click preview because this transformation applied in memory, and then you see it on the screen. And if you're satisfied with the result, you can click add, and this step is added in your flow. So we remove two columns. You can always review what you did here. Let's add some analysis here, and let's implement table summary. And table summary gives you descriptive statistics for each of the column. So you have your data table here, and then for each of the column, you have statistics like a count of all values, mean, standard deviation, mean, and max. So it could be useful for further analysis. So we click preview and then save. And let's do also some visualization. We can use a histogram. And for example, we would like to take purpose of the loan. You can select color and facets. And here we take loan status. So we compare our target with a specific feature called purpose here. And we have different histograms for each of the labels. Okay, let's do some feature transformations or feature engineering. So one of the most common used transformation is scaling of numeric data. So we can go to the process numeric, and we can apply scale value, and we can select scalar here. I use standard scale, and let's select column For example, clearly, normally you have to scale all numeric columns, but for this example, I'm going to scale only, let's say, loan amount. And we preview and add this transformation. So you can continue with this engineering. For example, to handle categorical columns, we'll also go to the categorical. We implement one hot encode, and we take one of the categorical columns here. For example, purpose of the loan, specify handling strategy and output style. For example, we like to have it in columns, preview, and add, and so on. For example, for this specific example, what you can do, you see the employee title is a text column here. You can tokenize this text. Again, very simple. You add a transformation and see what is available for text. So featurizing text. And we can, for example, do the vectorization, and we can apply tokenizer, can specify some parameters here, and we select column, of course, employee title, and output format, let's say vector, and preview. And if you look at the result, you see we have a new column, employee title featurized, and this is vector of employee title. So we add it. So you can go on and on to add your own transformation, but we stop here. And now we would like to export data. In this lab, we're going to use another option, how we can export data from Data Wrangler. So we're going to add a destination here, S3. And here, just specified dataset name. And I have to specify CSV location. Again, I take one of the string. And I can add destination. Now, as soon as I have destination, I can create a processing job. I select this destination node. You can also specify encryption key. You can name your job. And specify what compute instances you need to run your job and run your job. The job is run outside of SageMaker Studio. So if you go to AWS SageMaker console, you're going to see this processing job here, which is just started. This is our job here. So you see we have two inputs because we have two parts, and Data Wrangler going to process it, and then processing output is going to put it into this location in S3. The job normally takes, say, 5 minutes to complete. Let's wait till it's finished. Okay, the Data Wrangler processing job is done. It's completed, took 6 minutes. Now we have to take the file path, and the file is copied on the S3 by Data Wrangler processing job. Just list. Okay, and this is our file. Let's start SageMaker experiment. Again, go to Launcher and click New Autopilot Experiment. And we call it Launch. And now I have to specify this key. Sorry. Of course, in your automated pipeline, you don't need to copy paste all this, but I do. So we have to specify the target. Remember, Autopilot doesn't know what target is, and target is launch status here. And you also can select if you want to auto deploy the best model after the experiment is finished. So I select off because I want to deploy my own, and we can keep machine learning problem time at auto, and I run the full experiment. And basically that's it. So you can specify in your production environment, can specify encryption key and EBS volume encryption key for processing instances. Again, if you do it everything in your pipelines through API, you use just parameters to specify all this. So I think we ready to run experiment. We just have to say where all artifacts are going to be saved. Select this. And we can start experiment. Again, we redirected to progress screen with steps. What Autopilot is doing here, pre-processing, generating different candidate definition pipelines with different models and different pre-processing, feature engineering. Then the selected models are going through model tuning, and Autopilot generate explainability report and insight support. And at the end of the SageMaker experiment, you're going to see 250 model tuning jobs. Each model tuning jobs is registered as SageMaker experiment, so you can browse and see details for each of the model tuning jobs. Again, the full experiment takes on this data set probably about 2 hours. So I'm going to stop here and come back when experiment is ready. Autopilot experiment is ready, and we have a winner. The best model. Again, the models are ranked here based on the objective, and objective is F1. In this case, you can specify your own objective. In the best model, you can go immediately to the best model and view model details. And exactly as in demo 1, we see importance of the features for each of the labels. We see different metrics of the model, and we see the best combination of hyperparameters. In this case, the winning algorithm is XGBoost, not deep learning. So you cannot predict really what algorithm will be the best here, but we see that XGBoost is the best in this case. You can also deploy this model. We didn't select automated deployment, so you can take this model and deploy on your own. If we had selected automated deployment, we would have in endpoints a new endpoint deployed by Autopilot, and this endpoint can serve already real-time request and do real-time inference. Okay, I think this concludes the second lab, and now we are going to the third one. We move now to the lab number 3, demo number 3, and in this demo we try to handle time series prediction. Autopilot can tackle regression and classification tasks on time series data or sequence data in general. Autopilot uses a special library, TS feature extract, to extract additional features on time series. And Autopilot uses additional features on time series to create the model and run the training and do the prediction. Let's look at list of this feature just to understand what's going on behind the scene. So Autopilot uses this library, and we have a lot of features that can be extracted from the time series. For example, ABS energy and Benford correlation, all these features can be extracted and used as additional features on the data set, and Autopilot can run regression or classification tasks using these features. So let's try to do this. And of course, as with 2 previous labs, I'm using publicly available workshop. I'm using this cross-industry lab, and to get the data and source code, again, you have to copy paste this set of commands into your Studio terminal. It will copy the zip file and extract, and you have data set and a notebook. So let's go to SageMaker Studio. And this is a notebook. I do usual thing. I take the data set from EFS, from SageMaker Studio, and copy it to S3 to be able to use it in Data Wrangler. I'm also starting Data Wrangler and loading this data set into the flow. I have already created the data flow and applied some transformation and some visualization. Just be conscious of time. I just go now quickly through the list of transformations that I applied. You see, we have already 18 different transformations to prepare this time series data for Autopilot. Let's start with the source data. The source data, we have different features like ID and year, which is string, by the way, and not datetime. We have some other columns. We have some categorical columns, and we have numerical columns. And the column that provides some data for us is maximum temperature for this particular date and minimum temperature for this particular date. And temperature is in Celsius. So we have to divide by 10, and then you get the temperature in Celsius. The second step, as you see, we change the data type. So we change the data type for timestamp from string to datetime, and it's correctly recognized by Data Wrangler. Next step, we handle missing data on time series, and we provide timestamp column, and we can select the strategy. This is forward fill in this case. Then we handle missing for the temperature minimum. Then we create a new column called average temperature, and we use a Python Panda script here. Just create a new additional feature. It's very simple. We just take a mean of these two columns. Then we drop multiple columns that we don't need for further processing. And again, as I go through these steps, you see how the data set transformed. So this is our data set before column drop, and this is drop column, select, and I have this data set. So on the screen, I have always data set represented how it is in memory. Then we have additional custom step, and I take only data points. So I'm using PySpark SQL here. I take in only data points after 1995, year 1995, because we have some missing values before. Then I do resampling. Again, resampling is one of the transformation from time series, specifically for time series. And I resample based on the calendar day. And I take a mean between different numeric values. So resampling, what resampling does in this case, if you have multiple numeric values for a particular day, the algorithm average these values and write one value for particular day. So this is our data set. The next step is also specific for time series. I extract year, month, and day as a separate columns, you see, from timestamp. You can extract so any part of the timestamp. Then I drop columns that I don't need again. So I drop I don't need these columns, I drop them. I do resampling again on this one, on this case on the week frequency. Again, I average all values for the week and have only one value for a week here. So we see it here in the data set. Then again, I have custom step. I do rounding up to the next two decimals. I drop columns Tmax and Tminimum that I don't need because I'm only interested in average temperature. I apply some validation. You can have also validation transform. So I validate that my year date timestamp is always correct. Then I do the imputation of missing values on the numeric column. And again, using mean strategy, you have a selection of different strategies. Can I do approximate, median, or mean? And the next two steps, I do lagging. The first, I lag a year because I have weekly frequency and I take 52 weeks. So it's exactly a year. So this column additional, it's a year lag. And next step, I do again lag, but a 1 week. So this additional column is 1 week lag. And again, I drop columns that I don't need, timestamp, and my final data set is exactly average temperature, lag, year, and lag 1 week. When we go back to data flow, I added here destination, which is S3, meaning I can always create a job and specify this destination. And if I run a job, data Wrangler create processing job, SageMaker processing job, transform the data set based on the steps, and saves the output data set to the specified S3 location. Okay, now we have a file, exported file from data Wrangler with transformed data set, and we can start as SageMaker Autopilot Experiment. So click Create Autopilot Experiment and copy paste the path to the file. You can preview the data set, and you see it's exactly this transformed data set with the average temperature lagged 1 year, and average temperature lagged 1 week. So we name it prediction, and I'm going to leave everything on auto, so I don't want auto deploy. And in advanced settings, keep machine learning problem type in auto, and run the full experiment as always. Nothing new here. Of course, you can adjust the number of candidates, but leave it at 250. And we just specify as always, allocation for experiment artifacts. Click Create Experiment. Of course, I have to select the target, which is temperature average, and I create an experiment. Now we have to wait until experiment finished. Okay, our experiment is finished now, and we have the best model. Let's look at job profile. We see that Autopilot detected this problem type as a regression, which is correct. And we have, of course, our settings here, input data, model, and if we go back to the trials, so we see the best model, we can browse the best model details. The winning algorithm is NLP. And of course, we have, again, full data here on the performance. So for example, we see the mean absolute error is 32, is 3.2 grad Celsius. It's not so bad. And we have normal metrics, common metrics for regression. We have also links to all artifacts, input data, training and validation splits, transformed training and validation splits, feature engineering code, model itself, and explainability artifact. And of course, you can always deploy model as an endpoint, real-time endpoint for the SageMaker. So we've seen that Autopilot is also able to handle time series with additional feature extraction, time series feature extraction, and can be also very useful to handle the specific type of problems. This also concludes the lab number 3. In the last lab, we are going to look how you can access all functionality of SageMaker Autopilot from API or Python SDK. It's quite simple. 3 steps. In first step, you create AutoML job using, for example, Boto3 SDK. You have to set up input data config, output data config, use a specific execution role, and assign a job name. And then you run Autopilot Experiment. After Autopilot Experiment is ready, you can get detailed information on all model candidates. Again, I'm using Boto3 SDK here, API, and you can browse all candidates. And then you can deploy the best model candidate. Here, for example, we create model using the best candidate inference containers, create SageMaker endpoint for real-time inference, and then you can use the endpoint. This notebook example is available under this link. You can click or scan with your mobile phone. And now go briefly to the notebook. And again, I'm using one of the data sets here, tabular data sets, and running multi-class classifier. So what we're doing here, we're preparing the data, and now we start using Autopilot API. So I'm configure Autopilot. You can specify all parameters that we were using on user interface, specify where my input data is coming from, where all artifacts should be saved, and launching Autopilot Experiment. I can also track the experiment in progress via API and browse the results. For example, list all candidates, and here have access to the best candidate. So it's very simple to integrate Autopilot API into your pipeline, into your workflow, and use from your notebook. Now we at the end of our webinar. So what's next? First of all, we'll take a look at available resources and documentation. You can run the same demos that we just run here. Just click on the link or on the QR code and reach out to us with any additional questions at this email address. For the first steps with Autopilot and Data Wrangler, I suggest to start with SageMaker documentation. Some links are on this page. For more details, you can look into these blog posts and on AutoML paper with a lot of additional information how AutoML works. And for those who would like to be hands-on, this page presents a collection of workshops and examples. This concludes our workshop. Thank you for your attention and have fun with SageMaker Autopilot.